Okay, this problem is from section 6.6, which is solving rational equations. All right, with a problem this complicated, the first thing that you would want to do is get a common denominator. In order to do that, since your denominators consist of trinomials, you will need to factor each denominator. So the first thing I'm going to do is factor all these different denominators. Okay, the first denominator is going to factor into x plus 5, x minus 2. Now we sure know how to factor because we've already tested on this, so I'm not going to review the factoring skills. Okay, the second denominator would factor into x plus 3, x minus 2. And then your third denominator, which is after your equal sign, would factor into x minus 4, x plus 3. Okay, now your LCD, or your common denominator, is going to consist of all of the denominators you see the most number of times they appear in each individual term. What does that mean? Well, you look at each term and see what different denominators come up. So I'm looking for the LCD. I look at the first term. I need an x plus 5. I need an x minus 2. All right, if you look at the second fraction, you need an x plus 3, which we don't have yet, and an x minus 2, which we already have right here, so we don't need to write it again. Then if we look at the third, we need an x minus 4, which we don't have, and an x plus 3, which we already see down here, so you do not need to write it again. So this would be my LCD, x plus 5 times x minus 2 times x plus 3 times x minus 4. Very complicated, obviously. Now, the whole point of LCD is to eliminate your fractions. So what you're going to do is you're going to multiply this long LCD by each one of these fractions. For example, if you look at the first one, you're going to look to see what your denominator is missing, basically. If I multiply all four of these terms by this particular fraction, the x plus 5 and the x minus 2's are going to cancel out. So I'm left with x plus 3 and x minus 4. So now I've got 4 times x plus 3 times x minus 4. Okay, that's my first one. Now this 4 is just coming from your numerator. Okay, then I'm going to look at the second one. Again, look at all four of these terms and the 2 that you already have here. Well, you've already got the x plus 3, you've already got the x minus 2. So the 2 that you're missing is the x plus 5 and the x minus 4. So I'm going to bring down my 1 and put x plus 5, x minus 4. Okay, then your last one has got the x minus 4 and the x plus 3, so you need the x plus 5 and the x minus 2. So I'm going to have 3, which is my numerator, x plus 5, x minus 2. Okay, then at this point you can see, hopefully you can see the whole thing, that we eliminated the fractions, and that's the whole point when you have a rational equation, is you want to get rid of those fractions. So now what we're going to do is we're going to FOIL out all these binomial terms. I'm going to leave the 4, the negative 1, and the 3 alone for right now, and I'm just going to distribute or FOIL what you see in parentheses in each one of these terms. So I'm going to bring my 4 down, and I'm going to FOIL this out. Well, you're going to get x squared for your first term. Your inner and outer will give you a negative 4x plus 3x, which is going to give you a negative x. And then your last term is minus 12. Do the same thing with the next term. Bring down the negative 1. X times x is x squared. Okay, inner and outer, I'm going to get negative 4x plus 5x, which is positive x, and then minus 20. Okay, bring down my equals 3. I'm going to get x squared. Again, inner and outer, I've got positive 5x minus 2x, which is 3x, and then minus 10. All right, at this point, once you get it here, you're going to then distribute the numbers in front, so the 4, the negative 1, and the 3. So I'm coming back to the beginning. Let's distribute this 4. So I'm going to get 4x squared minus 4x minus 48. Okay, those are my first 3 terms. Now I'm going to distribute a negative 1. Distributing a negative 1 just changes your signs. So I'm going to get minus x squared minus x plus 20. Okay, and then my last term, I'm going to distribute 3. So I'll get 3x squared plus 9x minus 30. And you can see we've made this from a more complicated equation to not quite so bad. Still a little bit complicated. Alright, at this point we've gotten rid of the multiplication, we've gotten rid of the fractions. Now we want to combine our like terms that are on the same side. If you look over here on the right, none of these are like terms, so we're just going to leave them alone right now. Look on the left, and I'm going to combine what I can. Well, I can combine the 4x squared and the negative x squared. I can combine the negative 4x and the negative x, and I can combine the negative 48 and the positive 20. When you combine those, you actually do exactly what it tells you to. You do not change signs. The only time you change signs is when you're moving things from side to side, which we discussed when solving basic equations. So 4x squared minus x squared is 3x squared. Negative 4x and negative x is negative 5x. Negative 48 and positive 20 is negative 28. And then I'm going to bring down the other side. Okay, now if you notice, we've got three terms on both sides. So now we're at the point where we can just start moving things around. So what I'm going to do is I'm going to start by subtracting 3x squared. And if you notice, when we do this, both sides of 3x squared are going to cancel. So now I just have a basic multi-step equation. When I look at what's left, I've got negative 5x minus 28 equals 9x minus 30. So I want to get the x on one side and the numbers on the other. Well, I'm going to choose to move my negative 5x because I always move the negatives. So I'm going to add 5x. And like I said, this is when you do opposite sides, when you're moving from side to side. So now I've got negative 28 left here equals 14x minus 30. Alright, well now that I chose to move the x's to the right, I'm going to move the numbers to the left. So I'm going to add 30. And if you see, we're at the very end here, I'm going to get positive 2 equals 14x. My last step is to divide by 14. Now your answer is 2 over 14. Of course that can be reduced, so your final answer would be x equals 1 over 7. Now keep in mind, guys, on my math lab, when they ask you to enter an answer like this, they're going to ask for a solution set. So don't put x equals. You're going to put the little braces and you just put the number 1/7. That's a solution set. Hope this helps with solving rational equations.